really anything new in 5.6. The one thing that they do throw at you, and we've done this already, it's the fundamental theorem of algebra. And this is just the fancy name for the things that we've been talking about already. And it basically says is that if your highest power is x to the n, you're going to have that many solutions. I know we've talked about this for a few sections, and I went ahead and threw this out to you 3 or 4 sections ago when we were talking about it, because it was pretty simple. That whatever your highest power is, if it was x to the 5th, you'd have 5 solutions. X to the 4th, you have 4 solutions. We actually put a name on it now. It's the fundamental theorem of algebra. So that was one of those things that we've already done this, so we're good, because everybody has that idea for what we're doing for this thing. So they're going to give you a couple questions where they're going to give you a statement and just ask you, all right, how many solutions does this thing have? We'll do one just to make sure everybody has it. I'm pretty sure we do. So if A is our first example, we've got x to the 7th plus 4x squared minus 10x plus 27. They're just going to ask you a couple of questions, easy ones in homework. How many solutions does this equation have? There you go. And again, we've been talking about that for 2 or 3 sections. So that's one of those that we just go ahead and tell you because it's just that easy. Find the highest power, that's how many solutions you have. The closest thing to a trick question they would ask you is the terms aren't in descending order. But you still just look for the highest power. There you go. So you got negative 10x to the 4th. There's your highest power, so you have 4 solutions. Okay. And if you remember, in the first part of section 5, that's where we had to go back and do synthetic division with guess and check and just work through all those problems till we had the numbers we were looking for. This one's going to be kind of the same way. This is going to be one of those options where they're just going to tell you to solve. And they're going to tell you up front that the answers may be real or imaginary. And we're just going to look at just a bunch of different examples as we're going through this one, just to show you, all the options you could get from this part of it. Okay, so here's example 1. Again, we'll do 4 or 5 examples and just show you all the different options for what you can look at. And again, we're going to kind of basically walk through all the different ways that you can do the different things that are here just to kind of help you out. Alright, so very first thing is you have 4 terms, and here's what you want to do. Again, just kind of thinking through these. If you have 4 terms, see if you can do grouping first. So that's always the first option you want to do, is that if you have 4 terms, see if you can do factor by grouping. It's going to be about 50-50. Sometimes you'll be able to, sometimes you won't. So if we try factor by grouping, we're going to take the first 2 terms and put those in the parentheses. And then we're going to take the second two terms and put those in parentheses as well. And again, still take whatever that sign is that's here. Go ahead and take that sign with that number, just to be on the safe side that we don't get everything kind of out of line when we're doing this one. And I always put a plus sign in the middle just so I know that it's always going to be that way. And it kind of forces me to take that sign and put it on the inside. Okay, now again, if you're not good with factor by grouping, hopefully between you and the partner that you're working with, y'all can get this figured out. So if you have the first two terms, what do they have in common? Because all you're looking for is greatest common factor. X squared. There we go. All right, so take out the x squared. Leaves you with an x to the first power. Take out the x squared here. It's going to leave you with the 5. All right, and again, if we know factor by grouping is going to work, this parentheses is also going to be x minus 5. So if we've got 16 and 80. Now, obviously you can divide them by 2. You divide it by 4. Somebody may say, well, I've got 80 and 16. I can divide them both by 8, but there's a bigger number. There you go. 16 would work. If you do 16 divided by 16, that would be an x. If you do negative 80 divided by 16, that would be a negative 5. And that's what we wanted, because now you've got the same thing in the parentheses. So if we do that, we'll take the x minus 5, and whatever these two terms are that's here, they're going to go in parentheses in front by themselves. Okay, now we've got two sets of parentheses. We can solve this one real easy. Just do x minus 5 equal to 0. We'll add 5 to both sides. So that's x equals 5. We've got x squared plus 16. You can either do the quadratic formula, or what was the shorter way to do that one? If it's just x squared and a number. There we go. Square root the numbers, right? So if we square root the numbers, now before we do that one, we've got to get the 16 by itself and the x squared by itself. So we'll subtract 16. So we'll take it to the right-hand side. And then we can square root both numbers. Okay, and the only difference is that if this was 16, it would just be plus or minus 4, but because of the negative, got to put the I term in there. And there's, again, there's that complex conjugate thing that if you have a positive 4i, you're also going to have a negative 4i. And that always works because you're going to take the square roots there. And we started off with x to the third as our highest power, so we've got 1, 2, 3 answers, and that's the 3 answers we're looking for there. So it's still that same thing, that whatever your highest term is, degree-wise, that's going to be the number of solutions that we have. All right, now let me show you one where it's 4 terms where factor by grouping doesn't work, and then we'll figure out what we'll do from there. All right, and again, here's kind of what you want to do with whoever you're working with. We have 4 terms. So then you want to say, all right, can we do grouping? And just put a question mark, because it's going to be 50-50. Sometimes you'll be able to, sometimes you won't. And it just depends on the terms. Put the first 2 terms together and put the last 2 terms together. Now, first 2, that's exact same 2 terms we had on the previous problem, so we can take out the x squared. Be left with an x minus 5. Is there any way, because with 2 and 8, we can take out a 2. Is that going to leave us with x minus 5? No. So when you do these two things are different. If those are different, then grouping doesn't work. Now here's where we're going to get into, this is why y'all are in groups, because in this case grouping didn't work, so it's kind of an oxymoron, right? Grouping didn't work, so that's why you're in groups. If this is the case, if you do this one and there's no way you can do this factor by grouping, here's what we're going to have to do. You're going to have to do the P over Q thing. Find the factor, and again, if we're doing this one, P is 8. And then our Q in this case would wind up being 1. So it's the factors of 8 over the factors of 1. And the good news is, but since 1 is the first term, it's kind of like when we did the factoring. It's a little bit of a shortcut. We're not going to have as many options of answers we're looking at, because there's only 2 ways to get 8. It's 1 times 8, or it's 2 times 4. So all of our possible solutions is that, again, if this is over 1, it's a shortcut. It's basically just going to be these numbers up here. So we're looking at 1, 2, 4, and 8. Okay, with synthetic division, what was one of the answers that worked? Okay, we had 4, we had 2, we had -1. And again, just when you're checking these, the first thing I would say to do is start small. Start with plus and minus 1. One of you do positive 1, the other one do -1. Check it and go from there. That if you do that, somebody probably found -1 at first. And we had, pulling the terms back out here, 1, -5, positive 2, positive 8. -1 times 1 was -1. 6. Okay, so that meant that x equals -1 was one solution. Now, here's where you got two options. Because this thing started off with x to the third, we know that this one would have been x squared minus 6x plus 8. Now, one of two things. If somebody else is working through this, and we had this over here with this group a minute ago, that somebody was checking 4 and 2, I think it was. If you find two answers, because somebody said, all right, I found -1. Let's say you get here and somebody else says, oh, I found 4. Because 4 worked also, didn't it? What you can do is, you can either, two options here, you can either factor this thing to find the other answers, or if somebody else is doing this one and they find out that they had 4 as an answer, go ahead and do synthetic division with this thing with 4. So this would be 1, -6 plus 8. So that's the benefit of having two people working together, is that if both of y'all find an answer, y'all can work together to get this thing even shorter. So that's 1. 4 times 1 is 4. -6 plus 4 is -2. 4 times -2 is -8. That's 0, so there's your next solution. And since this one started off with x squared, that means this answer starts off with just x, so that's 1x minus 2 equals 0. And that's just a x powered term, right? So this one you can just add 2 to both sides, and there's your x equals 2. So there's your 1, 2, 3 solutions we're looking for this thing. Okay, now here's the other option, is that if we had done this one, and you didn't know that this, let's say you only found the one solution, that we'd gotten x equals -1 and we didn't have it, this is where you should be able to factor this thing to get the other two solutions. So if you check it, the factors of 8 that equals 6 would be 4 and 2. Make them both negative. So when you solve that one, you get the x equals 4. When you solve that one, you get the x equals 2. Okay, so whether you factor it or whether you get somebody that's got the next answer, either way is fine. It just depends on, I guess, what you kind of find as you're going through those. All right, let's give you another one here to kind of look at. Okay, so let's say that's our equation we're going for next. Now, here's the next thing. If you start off with x to the fourth, and you've got every term from x to the fourth to x to the third to x to the second to x to the first to just the constant, there's no way you can factor this one. Well, no way that I know of that you can factor this one just by telling you on this one. If you have one like this, where you've got all the powers of x to the fourth all the way down, you only have one option. You're going to have to do the p over q. So we're going to do the factors of 12 over the factors of, and again, the good thing is for this one, that first term is 1. So that's our q term, that 12 would be our p term. So it's the factors of 12 over the factors of 1. So really it's just the factors of 12 because the 1's not going to do anything to it, so it's going to be the factors of 12. 1 times 12 is 2 times 6, it's 3 times 4. So we got 1, 2, 3, 4, 6, and 12. Now here's the one big thing I want y'all to catch for that Descartes rule of signs. And this is the only thing you have to kind of notice. If you notice how all these terms up here are positive. So there were absolutely no sign changes, correct? If there are no sign changes in the original problem, that means there are no positive solutions. So for this thing, you've already kind of cut your work in half. So up here for this thing, if there are no plus or minus sign changes, that means there are no positive solutions. And that's using the Descartes rule of signs thing. And that's really the one time we're going to actually make this thing come in handy. So for this one, because there are no sign changes in the original problem, if there are no sign changes, there are no positive solutions. So now when you're checking these, you're going to check the negatives. Because there's no way that a positive solution is ever going to work on this thing. Okay, so we're going to pause right here. Y'all start checking the... Okay, so the first answer we found that worked was -1. So that's 1, 4, 7, 16, 12. Okay, bringing the 1 down, we've got -1 times 1 for -1. 4 minus 1 is 3. That's a -3. 7 minus 3 is 4. -1 times 4 is -4. -1 times 12 is -12 to get 0. Oh, sorry. Okay, so going through those numbers. We've got the one solution right now. We've got x equals -1. Now here's the question. Well, two questions here. How many answers are we looking for? 4, right? We've got 1, so we've got to find 3 more. We've got x to the 4, so that means we know we're looking for 4 solutions. We've got 1 answer right now. We've got to find 3 more. Here's where you have choices. Because if you wrote this thing out with this starting with x to the 4th, this would be 1x to the 3rd plus 3x squared plus 4x plus 12. Okay, now here's where you kind of get options for what you want to do. If you have 4 terms, you could do trifactor by grouping on this one. So we could do that. Now, here's the other option you could do. If you were in a group and you found 2 answers, what was one of the other answers that worked? All right, we heard 4, -4, and negative. Is it just -4? Oh, -3. Sorry. Okay, so somebody else said -3 works. So what you could do is you could take these numbers from here and do synthetic division with the -3. All right, if we do that, bring down the first number. Negative 3 times 1 is negative 3. That's a 0 term. Negative 3 times 0 is 0. 4 plus 0 is 4. Negative 3 times 4 is negative 12. That becomes 0. Okay, so now we have two solutions. Since this one started off with x to the third, now this one's going to start with x squared. This is 1x squared plus 4 equals 0. Now, if it's just x squared plus 4 equals 0, how could we solve this thing? Square root it, right? So now we could do x squared, move the 4 over here. The x squared equals negative 4. Square root both of the sides. So x squared is going to equal plus or minus 2 with the I term. So that's one of those, because those are imaginary answers, there's no more synthetic division that would work once you got past the negative 1 and negative 3, because now you've got the two complex solutions that's here. So the four answers we're looking for, we had negative 1, negative 3, 2i, and negative 2i. Those would be the four answers that we're looking for. So, and that's one where I want to kind of see that you could go back up here and do factor by grouping. And if you do factor by grouping, you would get this thing off to where one group you're going to have x squared plus 4. The other group we would have, either x plus 3 or x, depending on which ones you work with there. But at some point in time on these, for this problem, no matter what you do, you would have to set this equal to 0 to get your imaginary roots. Now, just to show you real quick what you would have gotten if you had done factor by grouping. Again, we'll just kind of cover up this bottom part so we can kind of see it here. Because let's say you're going through this one and you don't find that second answer. Let's say you only find the first answer. If you had done factor by grouping here, you could have taken out the x squared and gotten x plus 3. This one you could have taken out the 4 and gotten x plus 3. So you'd have x squared plus 4, and then your x plus 3. And now you're right back to the same boat we were. Set this equal to 0, and set this equal to 0. Okay, and again, it just depends on what you get. If you get two solutions and you're working through this one, I would say go ahead and take the answer you have here, do synthetic division again, and that way it's always going to keep knocking this thing down a power. If you only get the one solution, then if you get down to 4 terms, do factor by grouping. Because more than likely, if you get these from x to the 4th, you're probably going to have a factor by grouping that's going to work here. I think that's kind of the good thing about these, is if you start with x to the 4th, once you get one answer, you'll almost always have this, so it will factor. Greatest common factor. I mean, do factor by grouping. All right, so we've got one more of these, and we'll wrap this thing up. Okay, I'll show you one that's just a little tiny bit different. Alright, so let's go with x to the 4th minus 3x squared minus 4 equals 0. Kind of a trick question, but kind of not, just depending on how you want to look at it here. Alright, now here's the trick with this one. Alright, now depending on what you want to do, if you want to do synthetic division, you'd have to go back in and add zeros for x to the 3rd, and you'd have to add a 0 for the x. But here's the trick. Here's something I'm going to tell you. If you get this one where you go from x to the 4th to x to the squared down to just a number, there's a shorter way to get the answer. We're going to kind of do square root, but here's what we're going to do. Let's just pretend for a minute that this was just, x squared minus 3x minus 4. Are there any factors of 4 or negative 4 where the sum would equal negative 3? Yeah, 2 and 2's out, right? I mean, that's not going to work. So if we do -3, that would be a -4, because the sign here would go with a bigger number. Negative divided by negative would be a +1, right? And you may be going, well, that's great, but how's that going to work? If this skips, if you start with just the even powers going through these, here's what you can do. You can still do x plus 1 and x minus 4. But you're going to make this, instead of just x, the middle term is going to carry the weight. It's going to be x squared. Then you can set both of these equal to 0, right? So x squared plus 1 equals 0, and then x squared minus 4 equals 0. And now we're back to square root property, right? Get the x squared by itself. And then square root both sides. But when we square root a -1, yes, plus or minus 1i, or just put plus or minus I. And for the x squared minus 4, we can add 4 to both sides. And then we'll square root both sides. The good thing is, this one's just a regular 4. It's not a negative, so when you square root it, it's just plus or minus 2. Okay, so now that's the only time that one works that you can do that is if you skip, if it's only the even powers. If it's x to the 4th and x squared, then yeah, you could do synthetic division, but at the same time, you can just separate this off and just factor this and separate it here, so you have just x squared plus and x squared minus a number, whatever it may be. Synthetic division works, just it'll take a little bit longer. So that's kind of a trick one. Now again, if you don't catch the trick and you put the zeros in there and do synthetic division, you're going to find either 2 or -2 works first, and then from there you'll have 3 terms left, or x to the 3rd, and then you can do factor by grouping, and then you can kind of go from there.